Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the position vector of a point. In the last lesson, we learned how to multiply a vector by a scalar. We also reviewed the calculation of displacement and the addition and subtraction of vectors. Today, we are going to learn about the components of vectors and different vector operations. This is the last lesson of this unit, students. I hope that you are ready to begin. So far in this unit, we have been using geometric representation of vectors. Now we are going to study how to perform different vector operations using the components of vectors. To represent the position vector of AB, we need to construct a vector which has both the same length and the same direction. We must place its initial point at coordinates 0, 0, and its terminal is at P, which is the difference between 3, 3 and 1, 1. 3 minus 1 is 2. Therefore, the terminal point of the position vector must be placed at coordinates 2, 2. Here is the position vector of AB. Now consider this vector. It has its initial point at -2 and -1. Its terminal point lies at 5, 5. Students, if we were to move this vector so that its initial point lay at the origin, what do you think would be the new coordinates of the terminal point? Please take a moment and write down your answers.
Students, let's get ready. Begin. Time's up. let's get back to our lesson.
Welcome back, students. If you answered that the vector's new terminal point would lie at 7, 6, you were correct. As you can see, in order to move the vector's initial point to the origin, we need to move it 2 units horizontally and 1 unit vertically. Therefore, if the vector is to have the same direction and magnitude after its initial point is moved, the terminal point must undergo the same changes as well. In this case, we must move, add 2, 1 to coordinates of the initial point to bring it to the origin. When we add 2, 1 to the vector's terminal point, it comes to rest at 7, 6. These vectors are all equal, but they have different initial points. Of these vectors, the one whose initial point is the origin is called the standard form of the presentation of the vector. It is also called the position vector. If vector u equals vector OP, where O is at 0, 0 and P is the point at x, y, then vector u equals the column vector x, y. The magnitude of vector u is equal to the square root of x squared plus y squared. You may recognize it as being the Pythagorean theorem, written in a different way. Let us try making some column vectors for ourselves, students. Here are 4 position vectors. Please try to express all 4 of them as column vectors. You may get started right away, students.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. I am sure you were able to write out the 4 column vectors. Each of them should look like this. The column vector for OA is 3, 2. The column vector for OB is -1, 4. The column vector for OC is -2, -2. The column vector for OD is 4, -3. You can see that it is simply a matter of expressing the vector as a function of the x-coordinate relative to the y-coordinate. Here is a different vector called AB. To represent its position vector, we need to construct a vector which has the same length and same direction as AB. This means that we must construct a vector with its initial point at the origin and a terminal point that is the difference between the terminal and initial points. The column vector is therefore expressed this way. Using this expression, we can determine the vector's magnitude and direction. The tangent of the angle of a vector can be found in the ratio of the y-coordinate to the x-coordinate. You can see from the column vector that the ratio in this case is 1 to 1. The acute angle expressed by tangent 1 is 45 degrees. The magnitude of the vector is the square root of 1 minus 0 squared plus 1 minus 0 squared. In this case, the magnitude is equal to the square root of 2. Can you apply these principles, students? Let us use what we have just learned about vector components to solve the following problem. The position vector of P relative to the origin is expressed this way. If the magnitude of vector OP is 5 units, try to find the set of all possible values of the column vector xy. For this question, students, you can assume that both x and y are integers. Are you ready to answer this question, students? Please go ahead.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back once more, students. This problem might have seemed tricky, but it is not too difficult to solve if you remember to apply the formula for determining a vector's magnitude. If the magnitude of the vector is 5, then its square is 25. All you had to do was calculate all the integers whose squares add up to 25. For example, 3 squared plus 4 squared equals 9 plus 16. 9 plus 16 equals 25. The square root of 25 is 5. Therefore, 3, 4 is one of the values of the column vector. 0 squared plus 5 squared equals 25 as well. The square root of 25 is 5. Therefore, 0, 5 is also one of the values of the column vector. Here is the complete list. Did you remember to include negative values as well, students? Great work. You are showing a good grasp of column vectors. That is all for this unit, students. In the last set of lessons, we have learned all about vectors in 2 dimensions. We have learned about scalars and magnitudes. We have learned about displacement. We have learned about the addition, subtraction, and multiplication of vectors. Finally, we have learned about position vectors and how to plot all possible values for a column vector. Until next time, thank you, teacher. Thank you, students.